Hi, this is Guido from Vesta Automation, and today we're here to talk a little bit about the basics of pneumatics and pneumatic automation. There are numbers of reasons why today, and since decades, pneumatics is among the most preferred choice in industrial environments for automation. The first reason is that air is a renewable source. It's taken from the atmosphere and goes back to the atmosphere. And with new technologies for optimization in the compression of the air, it can also be considered a quite clean source of power. The second reason is that, as I said, the air enters the system and gets exhausted from the system without pollution. With new components that don't require lubrication, the air enters clean and comes out clean, as opposed to other sources of automation such as hydraulic, where the oil is always needed. The third reason is that air is a fluid. It can be compressed, it's elastic, and it can work on different weather and temperature conditions. Also, to be honest, pneumatic automation is quite cheaper compared to other kinds of automation and way easier to maintain and keep it functioning, especially if we compare it to electromechanic automation or hydraulic automation. This is the reason why in a number of industries and applications, compressed air and pneumatics are widely used. And this is also the reason why, since over 35 years, Vesta Automation is committed in designing and manufacturing components for pneumatic automation. So let's see how a pneumatic system works. From this picture here, you can see that the first component is the compressor that takes the air from the atmosphere and compresses it. Then the air goes to a tank or a reservoir, where once compressed, it can be stored. After that, the air goes on the grid. The first elements on the grid are air treatment units, also known as FRL, which stands for filtering, regulation, and lubrication. Filtering means cleaning the air and drain out the water. Regulation means regulating the pressure level. Lubrication is an option that can be used in order to provide oil to lubricate the movements. But now is a less and less popular option, and in most of the cases is not needed anymore. Then the air goes all across the grid, which is a system of tubes and piping bringing the compressed air all around the factory or the plant. Then we have the valves. The air goes through the valves, which decide the direction of the air and the way of the air to the actuator in order to make the movement. Valves can be controlled with electric signal, with manual signal, or with mechanical signals. The last component, of course, is the actuator, the cylinder, which is the element that actually takes compressed air and turns it into force to do the job for which the machine is designed. Now we need to ask ourselves a question. What is pressure? Pressure is a force against a surface. So in the case of atmospheric pressure, is the weight of the column of air on a square meter. So is the force of the weight of the air on top of all our heads. At sea level, in regular condition, the atmosphere is 1 bar. So we all live in a 1 bar atmosphere. In industrial automation, we can increase this pressure with a compressor. If you look at this scheme, you will see that the atmospheric pressure, 1 bar, corresponds to 0 bar industrial pressure or gauge pressure. On top of the 0 bar, you can generate force with compressed air. The range of the pneumatic automation industry is generally between 3 and 9 bar. Lower than that, we have the low pressure range, which can go under the industrial 0, which is vacuum. On top of that, we have the extended range. In a lot of industries for other applications rather than pneumatics, way higher pressures are needed, but we will be focusing on the range 3 to 9 bar. Now we need to get familiar with the concept of flow or flow rate. Flow is calculated in liters per minute, the amount of air that is flowing through a system every minute. And it's usually calculated in normal liters of air, which means air at the standard conditions of temperature and pressure. In this scheme, you can see how the whole system works. The compressor takes an amount of liters of air from the atmosphere. It compresses it, and then it goes into the system. You know, the tank, the air treatment units, the valves, all the way to the cylinder. The cylinder uses the compressed air, and then it exhausts back in the atmosphere. The same amount of air taken from the compressor and exhausted by the cylinder is the air needed for that kind of automation application. And this is a way to determine how much air is needed in an industrial application. Of course, we are not considering here small leakages, losses, or other things that can happen that make the air go loose. But in general, the same amount taken from the atmosphere is the one exhausted by the actuator. So what is the relationship between bar and normal liter? Let's have an example. Here is an open bottle, which holds 5 liters. So inside here, we have 5 liters of air at atmosphere pressure, 1 bar. So you can see the amount of molecules of air inside the bottle at 1 bar. If we increase the pressure, and of course close the cap, we can increase the bar by increasing the amount of air in the same space. You will see the molecules pressed against each other, and they tend to go back to the original state. So we will have the molecules of air pushing against each other to try to go back to the atmospheric state. In this case, we will start to see a force against the walls of the bottle. If we keep the cap closed and increase again the pressure inside the bottle, we will end up having the bottle explode, just like a balloon. So this is how you can use compressed air to generate force. But we're not here to play games and make balloons explode. So what if we take compressed air and we put it inside a full sealed aluminum or steel body, which is called cylinder? You will see that compressed air will try to escape from everywhere. If the cylinder is well sealed, the only place where pressure can express its force is on the piston, which can actually move. So the pressure of the air against the surface of the piston will generate a movement, therefore a force. Pressure multiplied by surface equal force. This force is expressed in newtons. 1 newton roughly corresponds to 0.1 kilogram force. So if we know how many kilograms we have to move or lift, we can understand how much pressure and how much surface we need in order to generate that force. If you look at this scheme that you can find in our catalog, you can see the relationship between diameter in square millimeters and pressure expressed in bar. And you can see how much Newton, so how much force you can generate with a cylinder of a certain dimension and a pressure on a certain force. But don't worry, we will get deep into that when we'll actually explain how cylinders work. Now let's take a little step back to try to really understand the relationship between pressure and flow. So we said that in a pneumatic system, the force is always related to the pressure and the surface. The speed of a cylinder is always related to the flow rate, the amount of air per minute. So if we can control the flow rate, we can therefore control the speed. Here's an example. We have 5 people, and these people are needed to break down a wall. So let's pretend these are 5 bar. This is the force needed to push down the wall. If we make these people enter the room through a small door, they will take 20 seconds. It will take time, so it will be a slow movement, and at the end they will have the force to push down the wall. If we make the door much bigger, it will take 2 seconds for the 5 people to enter the room and push down the wall. So the force will be the same, the force to do the job of breaking down the wall. But the time, therefore the speed, will be different according to the flow rate, which is determined by the size of the exhaust. So we have these objects called flow regulators or speed controllers. When we provide pressure to the cylinder, they will not interfere. But when the air is exhausted from the cylinder, a one-direction valve will close, and therefore it will force the air to pass through a hole. By a manual movement, we can control the opening and closing of that hole, therefore controlling the speed of the cylinder. Less air going out, which means a slower movement of the cylinder. Funny enough, we can also increase the speed of a cylinder or of a pneumatic actuator with a quick exhaust valve, which will work in the opposite direction. It will allow the air to get exhausted immediately from the cylinder, rather than going back to the tubes and the valves. In this way, we can increase a little bit the speed of a pneumatic actuator. This is how we control the speed. In order to control the force, we will need pressure regulators or precision pressure regulators. But we will find more about that in our video dedicated to Vesta automation series of pressure regulators. Thank you for watching.